So I kept going and didn't realize that it was going over 15 minutes. I don't like each video being more than 15 minutes, okay? I feel like it's too much. So let's look at this. I wrote on it, so I'm pretending it's not there. I see a y and I see an x squared. Y, x squared. That's y squared, but that y is not squared. That one's, both of them are squared. So that means it's a u, it's a parabola, it's going up. Okay? Now, in standard form, it's in standard form, so I just rewrite it. I like when it's in standard form, because then that part's already done. And then I go, hey, I can put it in factored form. Well, if I'm going to do factored form, I remember from the previous page when I did that, I magic X'd it. The problem is, when I do magic X, there's supposed to be a third thing there. So when there isn't a third thing there, that's when I do my half box. So I go 2x squared, 16x. Now some of you go, I don't need this half box. I can just do it in my head. Well, great, do it in your head. But some of us that need a box, it's so nice to know it's there when we need it. They both have a 2x, and then whoosh up an x plus 8. So I have 2x, x plus 8. And if you go, okay, then you set it equal to 0, and you get x equals 0, x equals negative 8. No, I'm not solving. I'm putting it in a different form. So this is the same thing, it's just a different form. This is the x-intercept. This is the x-intercept. These are the zeros. But that's not what I asked for. It doesn't say solve. Oops. Okay. Now I'm going to put this one in vertex form. If I'm going to put it in vertex form, you know what I'm going to do. I'm going to solve by completing the square. But this one's going to be a little bit different. The reason it's going to be different is, let's look here. So I have 2x squared plus 16x. Well, the first thing is there's nothing to move over, so I'll just put equals 0. That's kind of different. Okay, whatever. The problem is, though, if I put the 2x squared here, and I go x and 2x, let me zoom that in a little bit. That's not a square. A square means this side and this side are the exact same dimension, as the same as this side, as the same as this side. The problem is that I can't make a square with an x and a 2x. So I have a problem. And the problem is that I have to get rid of that 2. So I'm going to factor out the 2. We kind of did that already, didn't we, in factored form? Now I could take this and solve it by completing the square. So I'm going to go x squared, 4x, 4x, and then x, 4, 16. Now I take the 16 and I add it in there, which means I'm adding it here too. Okay? But the problem is, I didn't actually do an even on both sides. Because if I added the 15 in here, I really should have made that a little bit more clear. I'm so sorry. What I'm really doing is going, and I'm putting the 16 in there, which really means I'm adding 32 to both sides. Okay? So that means I need to really be adding 32, so it's even. Now this turns into 2 x plus 4 squared equals 32. And if we put it in vertex form, I'm just going to put it down here. Y equals 2 x plus 4 squared, and move that over. That is my answer in vertex form. So what's the difference between what we did here and what we did previously? If we have a number in front of the x squared, we have to take it out so we can actually make a square. And then when we make the square and we add that number, we have to acknowledge that it's really 2 times that. It is a vertical stretch, so it's twice as big, so I have to accommodate that on the other side. Okay, we'll do more practice, don't worry. So what would be the vertex on this? Negative 4, negative 32. Good. How many transformations are there? 3. What is this one? Vertical stretch by a factor of 2. What is this one? Horizontal translation, because it's being added or subtracted, not a straight shooter, left 4. Vertical translation, because it's being subtracted, down 32, or 32 down. Okay? So if I was going to do this, just to let you know, because I can't help myself, if I was to graph this thing, -4, -32, that's my vertex. My zeros are 0 and -8. So I could clearly graph this. And if I'm even really cool, what is my y-intercept? Well, there's nothing there. That's why my y-intercept is a 0. Okay? Let's go to the last one on the page. So I see an x squared and a y squared. Do you think it's going to be this shape? Nope, but I know it's in standard form. Well, it's not in standard form until I move that 4 over. So -4 equals 0. Now it's in standard form. Okay? So now I go, let's see, y is x squared? No, they're both squared. So if they're both squared, I know it's going to be a circle. So I know this is a circle. Okay? Now factored form. I can't factor this one, so this would be not applicable. Okay? We cannot factor it if it's a circle, but we can find the vertex. How can we find the vertex? We have to complete the square. But since I have an x squared and I have a y squared, I have to do it 2 times. So I got to make one box, and I got to make another box, which means I should reorganize this. X squared plus 2x, y squared minus 4y, and the 4 is already moved over for me, so that's helpful. Now, it is a square because it's x squared. If this was a 2, let's say, I would have to take out the 2 and then make a place for it. Okay? If this was a 4, I would have to take out the 4 and make a place for it. And then whatever I would go there, I'd have to multiply it by 2. Whatever would go there, I'd have to multiply it by 4. But since that's not happening and it's a cute little square already, I can go straight to boxing it. So let me make sure that this is gone. So that means I can go straight to x squared, half of it. 1 times 1 is 1. Y squared, y, half of -4. -2 times -2 is 4. Then I need to add 1, so plus 1. Nothing else is being multiplied, so I can do the straight 1. Then I add 4, and I add 4 right there. Now I can redo this, and I can redo this. X plus 1 squared, y minus 2 squared, plus, and then now let me rewrite it, x plus 1 squared plus y minus 2 squared equals 9. All right, let's see how fancy you are. What would be the center? -1, 2. Do the opposite. What would be the radius? Take the square root. If I was to graph this, -1, 2, right 3, up 3, left 3, down 3, there's my circle. Okay? All right, let's turn the page. Ooh, it's your homework. Yay. Okay? So we know you're onto your homework. They want you to put it in graphing form, which means they want you to put it in vertex form. So you know how to do that. I'm actually going to change this because I feel like I'm not a big fan. I want you to take out the 2 and I want you to take out the 5. Okay? So with that being said, you cannot use homework help. You cannot use homework help because it's a little bit too confusing. Okay? I want to remind you too, when you're dealing with the line of symmetry, it's that x value of the vertex. So whatever that x value is goes right in there. And that's for the line of symmetry. Okay, so you can't use the homework help if I took out those numbers. It won't be the same answer. All right, so it looks like they want you to graph these points here, and then you're going to make a triangle. So let's say I made a triangle. 1, 2, 3. Okay? Then they want you to classify the triangle. Do you remember when you would do things like if it was equilateral, which means all the sides were the same, isosceles if 2 sides were the same, scalene if none of the sides were the same? What does that mean you're going to have to do? You're going to have to find the distance. And that's when you're going to do the Pythagorean theorem. A squared plus b squared, sorry, a squared plus b squared, it'll give you c squared. If this was straight, then you're no problem. A squared plus b squared, you'll get that length. Once you get the lengths, if this is a 6 and a 6 and a 2, it's isosceles. If it's 6 and a 6 and a 6, it's the same equilateral. If this was a 16, a 26, and a 36, they're all different, scalene. And you can use homework help. Okay, we haven't really done this one as much, but if you actually graph this in Desmos, you should see it like this. And you should still be able to use what you've learned about transformations to help you. When it says locator point, they mean what's the vertex. Okay. X-intercept and Y-intercept, you can figure that out. Oh, congruency. Do you remember that when you're trying to find, so if I have this, A, B, C, let me zoom this out a little bit. And if I go like this, D, E, F, and I have a 1, a 2, and a 1, 2, 3. So how would I do the congruency? The first one doesn't matter. I'll just say triangle A, B, C is congruent to triangle. So do you notice how the A and the B have one nick? So I just have to make sure that the one that has one nick is where I start, okay? But I went from A that has the 3 there. So I can't start with D because that has a 1 and a 2. I would have to start with F. So do you see how that vertex has 1, 3? So I would have to start with the same vertex. And then it goes to B. And then it goes to D. And then now from B to C, so I go down that side. And that's the congruency. Okay? A lot of this stuff is like, oh yeah, and I remember, or why did you explain it? I totally get it. Oh, it's one page of homework. You'll be fine.